Welcome back. Hi everyone. Today, before starting, I want to tell you a few things. Actually, I want to thank all of you for this generous response you all have given us on YouTube. And this is the initiative that we have started in this coronavirus lockdown. And I hope everyone is fine and is maintaining and following the rules and the regulations that are being ordered by the local authorities and the government. So stay home, stay safe. And today we are going to start a new series of lecture about environmental engineering. As all of you know, it is one of the most important subjects in GATE and ESE. Every year we are being asked almost 40, if I give you the range, 40 plus minus 5 marks in ESE, and in GATE you can say 13 plus minus 2 marks. So on average 13 or 15 marks are being asked in GATE every year in this subject. So it's one of the most important subjects in civil engineering. And about the subject, if we talk about the environmental engineering, it's a very broad subject. People usually fear this subject and they will just say that I will just follow some topics, some important topics, and then I will just skip other topics. But about environmental engineering, I must tell you that it's one of the easiest subjects if you once know the concept, and then you can easily do all the numericals or all the questions that will be asked in this subject. So about environmental engineering, first we should know why we study environmental engineering, why environmental engineering is there. About environmental engineering, I can tell you it is a professional engineering discipline that uses scientific topics like chemistry, biology, ecology, geology, hydrology, you can say microbiology as well, you can say mathematics. And it involves all these subjects because we have to create the solution that will protect and improve the health of human life. That will improve the health standards of living organisms and will improve the quality of environment as well. That's why we study this subject. It's a very vast subject. It will include concepts from chemistry, biology, microbiology. It will include the concepts from mathematics everywhere, you know, and hydrology and hydraulics as well. You can say concepts from all these subjects, okay? And if you know environmental engineering well, then you will be good at chemistry. You'll be knowing some concepts from biology as well, microbiology, and mathematics, hydrology. Obviously, when we're calculating, we're using Darcy's law, and we're using specific yield, specific retention concepts, and also in sewers we should know the hydrology as well. And in self-purification of rivers, when sewage is is discharged in them, how they self-purify them, and hydraulics as well. So these are the topics which are included in this sort of engineering. But this environmental engineering is it's being studied in many branches of engineering. But in civil engineering, our environmental engineering consists of few things that I must discuss over here before we go and start the subject. And it's very important to have an overview of the subject before you start it. You should know where I am heading and what is the purpose and how I should retain the things. Now about civil engineering, we study raw water engineering in it. Raw water. We study wastewater engineering in it, and we study air and noise pollution. So this is the whole syllabus that we encounter in environmental engineering. Guys, it's very simple, but I will start from the basics over here. Now we will discuss about the raw water engineering. Before I will start the raw water engineering, I will tell you about some of the references you can go with, and you can just follow those references as well. But there's a lot of things that are being given in those references, and you need to follow as per your syllabus, as per the syllabus that's mentioned in your exams. If you are going for GATE or ESE or SSC JE, even IPATE is going to conduct this year. So for reference, I will tell you these things. You can you can download it from the Google, and it's Government of India Manual for raw water, and this is the first reference you can consult, and the second reference is Government of India Manual for wastewater. So these are the two references you can go with for the subject. Now let's start with raw water engineering today, and I'll be obviously discussing some of the topics that we have studied in raw water engineering, and I will be giving you the importance of those topics as well. And so for raw water engineering, the whole of the environmental engineering is actually divided like this. We have a source. Source is something from where we extract water, okay? And from this source, now the sources can be many. There can be surface sources, there can be subsurface sources. You have surface sources. Surface sources are like oceans, okay? Oceans like ponds. Now, why use word oceans? I'll just be explaining after this. We have ponds, we have lakes, and we have streams, okay? We have storage reservoirs and rivers, okay? We have rivers, I should write here. And about subsurface sources, okay? I'm just writing it in abbreviation form over here to save the time. So in subsurface sources or underground sources, you can say we have wells, we have springs, okay, and we have infiltration galleries, and all these things I will be explaining you in further lectures, the properties of all these things. Let's move ahead. From the source, actually, we extract the water, okay? We extract the water, and we supply it to a community. Okay, and this consists of raw water engineering. The way you extract the water from the source and you supply it to the community, all those things, all those pumps, canals, water treatment plant, maybe surface reservoir, the orientation of pipes, the distribution system, this all consists of raw water engineering, okay? And from community, when this water is used and it's returned back as sewage or the leftover, or which is not used, okay? And this community discharges this water back, okay? And then we discharge it in the form of sewage maybe, okay? And this thing from community back to source, this consists of wastewater engineering, okay? This is whole of the thing. That's why we study this. Because we have to provide water to a community. Water is a basic essential need of life, okay? From the community it is discharged back, okay? It is discarded now, okay? Now we have to orient all those pipes, and we have to have a treatment plant, okay? And we can discharge this water to a source for purification, for natural purification, okay? So this whole consists of the environmental engineering and a few topics which are air pollution and noise pollution, which we also will be studying in the upcoming lectures. So you have to stay with me, okay? We'll be discussing each and everything. We'll be doing some numericals as well, very important numericals, and which have high probability of being asked again. And the concepts related to them, we'll be discussing all those things. So guys, let me give you an overview of raw water engineering over here. If I talk about raw water engineering from source, from source we have a pipe network connected. I will write pipe 1. So we connect a pipe network into the source. Okay. Now the source can be money, as I have already discussed. Now then we install pumps. Okay. From pumps we actually draw water from this source. Okay. And then we have again a pipe network. I write pipe 1 over here as well, and then I will be telling you why I'm writing over here. And then we have a water treatment plant. Water treatment plant. Okay. So from pumps we supply this water to a water treatment plant for purification, for chlorination, because we have to check the chemical composition of water before we draw the water, and then we have to suitably select some methods to purify it, because from different sources we have different impurities. Okay, we have different physical characteristics of water, chemical characteristics of water, and biological characteristics of water as well. So we have to suitably select a method in this water treatment plant to make this water suitable for drinking. Okay, and then from this water treatment plant we have again a pipe network. I will again write pipe 1 over here. Okay, and pipe network, and we supply this water from this water treatment plant to a service reservoir. Service reservoir. So what is a service reservoir? Service reservoir is something where we actually store the water. Okay, and it is designed as per the water demand of the community. You can have different societies with different population. Okay, so as per the population and the future expansion of the population, keeping in mind the design life of the service reservoir, maybe it can be 60 years, 70 years, and in those 70 years how this society is going to behave in terms of population. If it's a fast growing society, then we have to keep that in mind as well. If it's an old society, it's an old city where the population is going to decrease with time, so we have to keep that in mind as well. So before designing the service reservoir we have to keep such things in mind. Okay, we have to look for the future expansion of the populations as well. So accordingly we design the service reservoir, and from this service reservoir we have a distribution system over here. Distribution system through which we distribute the water to the whole community. Okay, I will write pipe 2. Now, why I wrote pipe 1, pipe 2? I wrote pipe 1 over here, pipe 1 over here, here, and here, and here I wrote the pipe 2. There's an important point behind that, and it's been asked many a times in your exams like SSC, JE, and GATE as well. So basically, these pipes, this network of pipe 1, this network pipe 1, pipe 1, pipe 1, these are being actually designed for maximum daily demand, maximum QMD. You can write maximum daily demand, and I will be discussing these whole things. I'm just giving you a overview of the subject right now. We are just discussing the syllabus and some basic concepts regarding the raw water engineering. So these are actually designed for maximum daily demand. From source to pumps to water treatment plant, and from water treatment plant to service reservoir, we actually design these whole network of pipes for the maximum daily demand of the community. And this distribution system is always designed for maximum hourly demand or the coincident draft. So whichever is maximum, either maximum hourly demand or coincident draft. I hope this is not coming out of the board. Okay, so whichever is maximum out of them, okay, you can say maximum hourly demand or coincident draft. So this distribution system is actually designed for that. And in the further lectures I will be discussing about this thing, why these pipes are being designed for maximum hourly demand and why these pipes are being designed for maximum daily demand. And this is a very important thing. And one more thing I skip over here, when I was discussing the surface sources, I mentioned oceans, and it's like very much this, what I can say, it's something that is not expected because we don't extract water from oceans. But I must tell you guys, there's a country which is called Australia, okay? And in Australia, we don't have freshwater sources. We don't have ponds, lakes, streams or rivers from where we can extract the fresh water. They actually extract water from oceans, and that's salty water obviously, and then they use the process of reverse osmosis, okay, to get that salt content out and make the water fresh, and they supply it to the community. So that's why oceans, okay. So basically this whole thing which I have discussed over here, this source to pumps, this actually consists of raw water engineering, okay. And raw water engineering is very important subject. Now I will be discussing some topics that we encounter in raw water engineering. Before we start, we go into the raw water engineering topics, okay. Now let me rub it. I hope that you have just had a good look on this, and this whole thing has got now stuck in your mind, okay. Or if you want to write, you can pause the video and write these things. Now about raw water engineering. So in raw water engineering, we basically extract the water from the source and we supply it to the community. That is the whole concept behind raw water engineering, and that is the main purpose of raw water engineering of raw water. So let me write over here, raw water engineering, raw water engineering. Okay. Now in raw water engineering, we have one thing. The aim is to set up a raw water scheme. To set up raw water scheme. This is the main purpose of raw water engineering. Now the topics that we encounter in raw water engineering are these. First, water demand. Second is sources of water. Third is quality of water. And fourth is treatment of water. Fifth is surface reservoirs. The sixth topic is pipes, pipe network. Seventh topic is distribution system. Okay. Now, before we have to design a raw water scheme, we have to know the water demand of a society or of a city. You are aiming to set up a raw water scheme, and then we have to study about the source of water which are available to supply the water to this city, and then we have to analyze the quality of water of that source, and then we have to go into the concept of treatment of water, because according to the quality we have to treat it. There can be different qualities of water in different sources, so we have to treat the water accordingly. And then we have to design a service reservoir, as I said, that is wholly dependent upon the population of a city and the future expansion, the growth curve of that, and we'll be discussing that in population forecasting. And then we have a pipe network, which sort of pipes, what's the dia of those pipes, how we lay them, what are the important factors, characteristics of those pipes that we lay, and then finally we will study the distribution system, and finally we can supply the water to the community. So these are the topics. If I tell you about the weightage of this topic, let me tell you, if this is 1, I'll give 2 weightage, I'll give this 5 weightage, I will give this 2 weightage, 1, this 2. So as per the weightage, the treatment of water, in the treatment of water you will see every year a question asked in GATE and ESE as well. and in quality of water as well, service reservoirs and distribution system, you will see lesser number of questions being asked. And about water demand, these are the easier topics, that's why they don't ask such questions. You can see the questions on these in other JE exams, but we'll be discussing whole of these topics to fully master this subject. Okay, you just have to stay with me. Okay, and if you like the content, you just mention in the comments, and if I need to improve on some part, you can also mention that, and I'll be extremely happy for your response. Now let's start with water demand. Let's start our first topic, that's water demand. And before starting water demand, I must tell you what we mean by raw water. What do we mean by raw water? Raw water is simply it's any sample of water which is being utilized from the natural sources and not being subjected to artificial treatment. You can say like that. It is simply untreated water. It's not treated by humans yet. It is a water that is in the source itself. Okay, that's called raw water. And then when we treat it in treatment plants, then this raw water is called as treated water. Okay, and now let me start from here. Water demand. Water demand. Now, as the whole term mentions itself, what is water demand? Water demand is simply the demand of water required. It's the amount of water required by the community. Okay, now when we study the water demand, we have different demands, we have different drafts. We can say demand or draft. These are one of the same terms, demand or draft. We have annual draft. First of all, annual draft. Annual draft. What's annual draft? This is the total amount of water required by the community in 1 year. This is called annual draft or annual demand. We can, if I write here, let me represent it by V. The total volume of water that's required by a community in 1 year. Okay. Now, if I say what is the amount of water that's required by that community in 1 day, okay, that I will write it average annual daily draft, isn't it? Obviously, I will tell that I will just explain that term as average annual daily draft. That is the water, the total amount of water required by this community in 1 day. And what will be that equal to? That will be simply equal to V divided by 365. Isn't it? It's very easy to understand that the average annual daily draft is equal to the total draft, the total annual draft required by the community divided by the number of days. That is 365 in a calendar year. Okay, so that will give me the average annual daily draft, or what I say, the draft is demand. So don't get confused. Demand and draft are one of the same things. Okay, then if I simplify it again like this, if I say what is the total amount of water required by the community in 1 day by each individual. Okay, when I say average annual daily draft is equal to the total amount of water required by the community in 1 year, in 1 calendar year, divided by the number of days, obviously. And when I say what is the total amount of water required by the community in 1 day by each individual, okay, so obviously I will be dividing it by, I will be dividing this term by the total population, isn't it? So this will give me the annual average demand per capita or per person, isn't it? It's very simple. Now this will give me the annual average demand per capita or per person, annual average demand per person. Okay, so these are the terms that we actually use in water demand. Okay, now this P is the population, as I said. So if you are writing, you should make some compact notes out of this thing, okay, so that this will help you in quick revision as well. So this is the whole thing about the water demand. Okay, that is, so we have gone to a point where we state that the annual average daily demand per capita. Yeah, here you should write daily. Annual average daily demand per capita. That is simply the total amount of water divided used by the community in one calendar year, divided by the number of days in the calendar year, and divided by the population. So let's go to some important concepts regarding water demand, because we have different water demands. Okay, we have different water demands in the community. First is domestic water demand. Domestic water demand, WD stands for water demand. The second is industrial water demand. Third one is institutional water demand. Fourth one is your water for public use. Fifth is your fire demand, because fire is an important thing that we have to take care of. And then you can say losses. So domestic water demand, as the term itself suggests, is the amount of water required to satisfy the domestic needs. Like you have drinking, okay? You have drinking, you have cooking, you have washing, you have bathing. So the amount of water that is being consumed in these processes is called as domestic water demand. And if you talk about the typical quantity in a country like India, you can have a value of 200 LPCD, liters per capita per day. Liters per capita per day. It's actually based on the annual average daily demand per capita that we have calculated before, and that is, the value is 200. This value is being asked in SSC and JE exams. Just remember this forever. And if you talk about the range, 135 to 225 LPCD, but the typical value is 200. Okay, around 200 plus minus 10-20 you can have, but the typical value is 200 LPCD. Okay, so this value is actually for a city having full flushing system. Okay, full flushing system for a city. For that city, the domestic water demand is in the range of this 135 to 225 LPCD. Now, what about industrial demand? Industrial demand is the amount of water required to satisfy the industrial needs. Simple is that. Now, what is the typical value of the industrial demand? It is for an average Indian city, it's of the value of 50 to 450 LPCD. Now, how do we calculate this industrial water demand? It's very important. How do we calculate it for a society? Now, you have a village, okay, where there is no industry, so there can be there is no industrial water demand, obviously, and there can be few factories. Okay, that's why the range is so much, 50 to 450. But in a city like Delhi, okay, you have a lot of industrialization over here. Okay, so you require a lot of water while you are designing a service reservoir. You have to keep in mind the industrial water demand as well. How do we calculate the industrial water demand? We actually see the total number of industries in a city, okay, total number of industries in a city, or then we actually calculate the amount of water that's required by those industries in one calendar year, okay, the total amount of water that is being consumed in the industrial process in these industries in one calendar year, and then we divide it by 365 and by the population, so we get the industrial water demand of that city, okay. It's actually converted in terms of the population, okay. It is not by the industries, it is divided by the population, so we get industrial water demand, okay. LPCD, liters per capita, per person, okay. So you have to the value itself, the unit itself indicates that it is converted in terms of population, so never get confused. It's the amount of water that is being used by the industries divided by the number of industries. It's not like that. It's converted in terms of this, okay. Then we have institutional water demand. In institutions, like we have schools, hospitals, railway stations, you can say airports as well, okay. It's the amount of water required to satisfy the needs of different institutions, okay. So this is the industrial water demand. And if I talk about the typical value of the water demand of institutions in India, it's of the range of 20 to 50 LPCD. So in an institute, on an average in India, 20 to 50 liters are being used per capita per day by a person in one day. 20 to 50 liters. Now, water for public use. Now, what is this quantity? Water for public use. It's the amount of water which is required by public utility purposes, like washing of roads, gardening, okay, etc. So you can say these terms, you can include these terms, such terms in this. So the typical value for water for public use is almost 10 to 20 LPCD. It's again converted as per the population of the city, and then we get the value. We have averaged it for whole of the India, for whole of the country. Now, what about fire demand? Fire demand is a very important demand that we have to consider while we design the whole process. So it's the amount of water that's being required in case of fire breakout. In case of fire breakout, the amount of water required is called fire demand, and it's taken as 1 LPCD. Just remember this. Or it can be found empirically for a given city. Okay, and fire demand, if I mention some important formulas, and these formulas are being asked, fire draft, if I talk about the Government of India manual, they give a formula, that's an empirical formula. They give fire demand is equal to 100 root of P. Okay, and this is this value is in kiloliters. As I said, these are empirical equations, and empirical equations are always area specific. They are based on observations. Okay, so 100 root, the population in thousands. Population in thousands. Okay, for example, you have 2,000 population of a city, then you have to put the value of 2 over here, not 2,000. Okay, population in thousands, and again we have an important formula by which we calculate as an empirical formula as well. That is called as underwriters formula. I guess, yes. According to National Board of Fire Underwriters method, underwriters formula. This is one of the important formula that also asked. Fire demand by this formula is equal to 4637 root P 1 minus 0.01 root P. As I remember it correctly, okay, 4637 root P 1 minus 0.01 root P, and this gives you the value of discharge, liters per minute. It is not, it doesn't give you the volume directly, it gives you the discharge. This quantity of discharge is required for a population of P. P is again in thousands over here as well, Okay, so that's how you have to keep this factor into mind while you design the distribution system, the service reservoir, and all those things that we require. Okay, then we have losses and theft. Loss and theft, that they are simply the amount of water which is being wasted out due to leakages, okay, and theft in raw water scheme. Okay, so this consists of almost 10 to 15% of total water demand. So the standard lengths of pipes which are being available are standard lengths of pipe. So this was all about the water demand. Okay, and let me go towards the pipes, giving you some basic concepts of the pipes and the ferrule point as well, up to which the government authorities actually supply the water to our houses. Okay, let's discuss that as well, because that's also an important point to mention over here. So first of all, let me tell you some important things on which the water demand depends upon. I can write it here. Water demand depends upon. First is size of city, obviously. Size of city or size of the community. And then we can have extent of industrialization, we can write here. We can say the type of lifestyle, isn't it? If you have a highly lifestyle, good lifestyle, then you use more water. Then again, you have climatic conditions. So in hotter climates, people may use more water. And then the fifth one can be the type of distribution system. Sixth, you can say the cost of water, isn't it? You have different units. And seventh, you can say quality of water. See guys, there are two terms. One is water demand and second is consumption. So if I talk about the cost of water and quality of water which is being delivered, which is being supplied to the community, they will actually affect the thing that's called consumption. If water is costly in your area, you will say, oh, it's very costly, we should use the water very sincerely. We cannot waste water. Okay, so that's actually affecting the consumption. That's not water demand. Water demand is constant. It's like domestic water demand. You need water for drinking. You need water for cooking, washing, bathing. You need water for industries. Okay, so that will these will actually affect the consumption, not the water demand. But these things, they will obviously affect the water demand. Okay, they will obviously affect the water demand. Okay, so this was all about the water demand today. Now, what about the pipes that I mentioned that we should discuss here before closing this video, this introduction video about the environmental engineering? Hope everyone's enjoying the concepts, and if you have any comments, you have anything that you wanna tell me, you can just write that in the comments. Now, as I told you about the ferrule point, when we have a distribution system and we supply the water to a community from a if this is my house, okay. So up to this point, actually, government authorities supply water. This is called a ferrule point. Ferrule. It's called a ferrule point. Okay, and this ferrule point, and up to this ferrule point, the dia of the pipe, which is being used by these government authorities, that's 10 to 15 mm. The dia of this pipe, okay, up to ferrule point, this is 10 to 15 mm. Okay, and the pressure which is being delivered at this ferrule point is of the order of 10.5 to 12.5 meters. 10.5 to 12.5 meters. Why? There's a logic behind it. Because most of the houses in India are double-storied, two-storied buildings on an average. Okay, so what is the average height of a single story? It's like almost 3.5 meters. Okay, and the second story as well, 3.5 meters. So we get a total of 7 meters. And then we have a tank over here, but before that we actually install a stand, and the height of that stand we can write 3 to 3.5 meters, maybe 3.5 meters. Okay, and then we have a tank over here. Okay, so from this ferrule point, actually when the pressure is 10.5 to 12.5, it gets directly, without any pump or other things, it directly gets it can be directly transferred by its own pressure into the tank. It can be stored into the tank. That's why the pressure has to be 10.5 to 12.5. Now in most of this, obviously our designs are not that much accurate. Maybe we don't have that much of pressure, so we have to use those pumps and all those things to generate the pressure. Okay, so this was the intro lecture on environmental engineering. In next lecture, we'll be discussing about the population and the peak factor, the fluctuations in hourly demand, Goodrich formula, and then we'll be discussing the population forecasting. Okay, so hope you have enjoyed the video. Please don't forget to share the video. Okay, and just press the bell icon to get the notifications. Thank you very much. Thank you.